Namaskar students. In my previous video I discussed about some basics of logarithms, and here in this video I will discuss about the properties of logarithms. So without wasting any time, let us start. First of all, I explained you that if x to the power y is equal to z, we can write this value as log of z to the base x is equal to y. Okay, so here some restrictions are there. It also comes under properties, so I'm explaining you once again, okay, because you do not do any mistake. These things are very crucial, okay, to understand any property, to apply logarithms in any other question. Okay, so let us understand that y here can achieve any real number, okay, while x and z, they are positive. It can achieve any real number greater than 0, okay, they can belong to any real number r plus. Okay, here x cannot be equal to 1. These were the restrictions on them. Now first we see that the x to the power 0 becomes 1. We know that if x is any real number, x to the power 0 is 1. So let us see, if we write this fact in terms of logarithms, what happens. Okay, we can write log of 1 to the base x becomes 0. Okay, so what does it mean? It means that x is any real number. Okay, here x is any real number. It means whatever is the base, the value of log 1 is always going to be 0. Okay, this is very important thing. Now we know that x to the power 1 is equal to x. It means that log of x to the base x is equal to 1. Here also x belongs to r. So what does it mean? It also means that x and x, it means if these two things are same, okay, the value of the logarithm and the base, if these two things are same, then the value is always 1. Okay, let us see some examples. If we see log 1 to base 20, okay, what is this? If someone asks, quickly you can say it is 0. Okay, if see log 1 to the base suppose 435, okay, so without any calculation you can say the value is 0. Okay, any positive number, fine, the value is always 0. Now what happens here? We see some examples. Log 3 to the base 3, what is this? This is also 1. Log 10 to the base 10, this is 1. Similarly, anything can be there. Log 200 to the base 200, the value is 1. Okay, there can be many such examples. Log x to the power m, if the base is a, the value of this expression is m log x to the base a. Okay, this is very important. If any power is there to this value of log, then this power gets multiplied with log x. Fine, the base remains same. Let us see some example for this. Suppose we have log 1000, okay, and here it is 2 or any base. So we can write this expression as log of 10 to the power 3 to the base 2, and this power or this exponent will come in multiplication here, log 10 to the base 2, okay, like this. So this is the advantage of this application or this property. Fine, if there any exponent or power of the base, then what happens? If the expression is like this, log of x where base is a to the power n, okay, so this power of base can be removed. Okay, so it will come like this, 1 upon n, and the remaining term will remain same. Now let us see some example of this. What is this exponent? This exponent means 2 raised to the power minus 1. 1 upon 2 means 2 raised to the power minus 1. Okay, so this power minus 1, okay, this will come here in multiplication. Okay, 1 upon this. So this expression becomes minus log of 5 to the base 2. So this is the application of this. Now if we combine these two, we get a general formula. If log of x to the power m where base is a to the power n, then this value can be written as, both exponents can be removed. Okay, this becomes m, okay, by this formula, and this n will get 1 upon n. Okay, and this whole value will be multiplied to log x to the base a. Fine, this formula is very, very important. This three set of formula are actually very, very important. Okay, they are used in many questions. In fact, each and every property can be used anywhere, but they are extremely important. Extremely important. Let us see example of this. Log of 10 to the power suppose 5, and here the base is 2 to the power 3. Then quickly you can write this value as 5 upon 3 log of 10 to the base 2. And whatever is the value, okay, the exponents are always, they can be taken out from logarithms. Log of xy to the base a. If this kind of expression is there, it means product of two values in logarithms, then these values can be written separately. Okay, this base will be applicable to both of them. Fine, this is also used at many places. Let us see some example of this. So we can write this value as 10 can be written as log 5 into 2. Okay, so this value can be written as log 5 to the base 2 plus log 2 to the base 2. Okay, and whatever simplification is there, further we can do. But according to this formula, if there is a product of values, then it can be written as sum of logarithms of separate values. Okay, now let us just quickly see how can we write this value. Okay, let us assume this value as p and this value as q. Okay, so log of x to the base a becomes p, log of y to the base a becomes q. So what we deduce from here, we can easily write that a to the power p, this is actually x. Okay, from here we can see that a to the power q is actually y. Okay, so from 1 and 2 can we multiply x and y, because here we require x and y. So let us multiply x and y. So we get a to the power p into a to the power q. Okay, so what we see here, the base is same. Okay, so the exponents can be added. Okay, they can be combined. So a to the power p plus q. So now we get xy is equal to a to the power p plus q. Okay, so xy is equal to a to the power p plus q. Now can we take logarithms both the sides? So let us apply log both the sides. Log of this expression is equal to log of this expression. In this property we see that the base is a everywhere. Okay, so we also take the base a only. Clear? According to the formula. Now what happens here? This value is same. We can apply the previous property that this exponent will come out. So this will become p plus q into log a to the base a. Okay, there was formula that log a to the base a, if these two values are same, then it is equal to 1. Okay, so this value is equal to 1. So we get p plus q. And what is p and q? Okay, p means this value and q means this value. So let us put the values. So this is log of x to the base a and log of y to the base a. In this way we can prove the formula. It is applicable at many places. This derivation actually helps a student in understanding how this formula came. If we have log x upon y to the base a, similarly it can be written as log x to the base a minus log y to the base a. Okay, we have base change formula also. The base change formula says whenever log a to the base b, this kind of expression is there, we can always write this as log a whole upon log b. Okay, here the base can be any positive real number, okay, except 1. Now what is this base? X. Okay, x greater than 0 and x not equal to 1. This base was b and we have changed the base, so that's why this formula is called, or this property is called, base change formula or base change property. Now one more application of that, we can see log of a to the base b, this can be written as 1 upon log of b to the base a. It means base and the value, they can be interchanged. If we take the reciprocal of that, okay, then the base and the values, they can be interchanged. Okay, we can understand this thing, okay, from this formula. If at this place x, if we take both base a then we see what happens. This log a to the base a becomes 1. Okay, so this value is actually 1 upon log of b to the base a, and we get this derivation. Okay, so this formula is just a special case of this formula. Whenever we say log x to the base a, here there are 3 possibilities. Okay, for the base, this base a can be of 3 type. This base a can be 10. Okay, this base a can be number e, and this base a can be any other real number. Okay, so what are these possibilities? Whenever we say log x to the base e, this e is actually a rational number which is 2.718281. Okay, this is an irrational number, okay, which is lying between 2 and 3. So wherever logarithms are defined on base e, so they are known as ln x. Okay, that is natural logarithms. Okay, and many times we call them simply log x, natural log or natural logarithms. This is one type of base. Another possibility is whenever the base is 10. Okay, this is known as common logarithms. So what happens with common logarithms? The values of log tables are actually defined on base 10, as well as for base e also. Okay, but it is sometimes it is easy to study when the base is 10. Fine. Beside this, log can be of any other real number. Okay, we know the value of a can be greater than 0 and a is not equal to 1. It means a is any positive real number lying in this range. Okay, so that can also be the base, but keeping the uses in mind, we study 2 type of logarithms, mainly that whenever log base e is there and whenever log base 10 is there. It is just a third possibility that base of logarithms can be any other positive real numbers. Now in this video we have seen the properties of logarithms. Keep the size of the video limited. We will discuss the practice questions in the next video. If in YouTube search bar, if you write my name and teacher, then you can go to my channel and you can see more videos made on many other topics. Okay, so get the benefit and help other students also, so that they can also get the benefit. Thank you for watching.